Here we begin with a function, f of x is equal to 3x plus 5. And then we're going to evaluate this function at a specific value of x. That value of x is -1. So we just want to evaluate or determine what f of -1 is. So every time we see an x, we're going to replace it with -1. So we have 3 times -1, and that's it. So then we just expand this out in the normal arithmetic way and see what we get for this f of -1. So we have f of -1 is equal to -3. So 3 times -1 is -3, plus 5 still. And then finally we have f of -1 is equal to 5 minus 3, or 2. So that's our final answer. F of x evaluated at -1 is equal to 2. So here we're going to have two functions that are inequalities. We're going to simplify them a little bit so that we can plot them on this endless plot here, see where they intersect, and then we're going to see what solutions we have by which region of space is subtended by the inequalities. So we have these two functions. We have f of x is less than x minus 1 minus 7. So this can immediately be simplified to f of x is less than x minus 8. So there's one. Now the other function is f of x is less than negative quantity x minus 1 all minus 7. So we need to just expand this negative through this x minus 1 and then simplify. So that gives us f of x is less than negative x plus 1 and then minus 7. And then this can simplify to f of x is less than negative x, and then we have minus 6. So here are the two functions that we want to graph, that we want to plot here, and then we'll just see where they intersect and what our solutions are. So let's start with this one. It's already written in slope-intercept form. We have the intercept of -8 and a slope of just 1. So if we go down to -8, that's 5, 6, 7, 8. We know we start here. Positive slope of 1, so up 1, right 1. So we have some slope and some plot like this. It is less than but not equal to, so we need to draw this with a dotted line rather than a solid line because it's less than but not equal to. So it's exclusive, not inclusive. Okay? And then we have this one. We have a slope of -1 and a y-intercept of -6. So here, -6, and again it's less than but not equal to, so we're going to end up using a dotted line. Slope of -1, so the opposite slope of this, so down 1 and to the right 1. So they do in fact both cross at this point here. And then again, like I said, connecting with a dotted line. Great. So we have these two lines, these two inequalities plotted on this together. We want to see where these regions overlap and where our solutions are. So we have a few different possibilities here. If we look at this first plot, we know that f of x is less than this line. So the y values, or the up and down, are less than. So the answer is less than this. So we're going down from this line. So in other words, we're interested in anything over here. Anything over here from this line. From this, it's the same. F of x is less than this line. So down from this line. So it's anywhere here or anywhere here. So this is only included for this line. This region of space is only included for this line. This is the only region of space that is both solutions to both of these plots. So in other words, if we want to, we can shade this region here, and this is our final answer. So sometimes we leave these plots as it is with the dotted lines, and we just shade this region however you like. But the solution is, in fact, this whole region of space. It's not one solution. It's not where these cross each other or where these intersect in the normal way, but with inequalities, it's an entire region of space. So our solution is actually all of these values here. And then what you can do to test is just plug in any value down in this region, any value of x and y, and make sure that it holds true. So for example, if you plug in -10 to either of these functions, then your answer should be a true statement. negative 10 is in fact less than whatever you have on the other side. So when you evaluate it at that value. So here's our final solution. You can test with any point you like, but that's all there is to it. So here we have a linear equation. Y plus 2x equals 1. We want to be able to plot this. And of course, we can always take any values of x or y. We can just say pick 0, for example, and find what the value of y is going to be. Or we can rewrite this in slope-intercept form and then just plot it directly. So let's do the latter. I think it's a little nicer. It's actually a little easier once you can do it. So all we need to do is have y by itself on one side, and then we're basically done. So subtracting 2x from both sides gives us y equals negative 2x plus 1. So that's it. We have the slope is negative 2, and the y-intercept is 1. So the slope is just the coefficient in front of the x, and the plus 1 is our y-intercept. So y-intercept meaning where it crosses this axis here. So that's 1. So we have this point, and we really only need 2 points or 1 point and a slope to graph. We have the slope, we have a point, so now we just need to make another point and then connect them. So it's a negative slope, so that means we're going down to the right. So that's important to keep track of. If it's a negative slope, we're going down to the right like this. If it's positive, then it goes up in the normal way. So down 2, 1, 2, and to the right 1. So negative 2, 1, 2, and to the right 1. So here we've got 2 points, and we can extend that in either direction now, and that's it. So if we can just connect these, we have our linear function, and it's plotted just